Da-da-da.
There we go.
Give it a go.
So welcome everyone to week 11 already. This is crazy. We're really close to the end of this program, fast and fast. We are going to talk about today about licenses and standards. I'm sorry if I'm a bit slow because it's a holiday here, so I'm not working. So yeah, I may be a little slow. So as usual, this call is recorded. As you know, you can turn off your camera. We will be uploading this. And the idea for today, next slide, please, is to do the icebreaker exercise. You've been doing that already. We've been learning about the weather where you are. That was really good. Thank you. And the agenda for today is to talk about, sorry, can we go back to the previous one? To talk about the content of week 11. As you know, cohort calls are for peer review in general. So what the format we are following is that the previous week we have, if you have been following the curriculum very, very tightly, you should be start reading. You should start reading about licenses and standards. We do know that the curriculum has a lot of content. So our idea with this cohort calls is to give you the overview of the module we are working on this 2 weeks, which is licenses and standards. So you can then more easily dive into the curriculum and do the assignments and try to read more deeply. But if you didn't have the time to do that, then this call will hopefully serve as a very good introduction to the topic, and then you can go back to the curriculum. So yeah, how do we arrive here? Well, 2 weeks ago, on week 9, I was not here because I was on holiday, but you were probably discussing road mapping, the road mapping model, all about how to plan the path for your project towards the future, and how to plan backwards from there to try to understand what you need to do to get there. And 2 very important questions, which are how to manage time and how to evaluate risks so you don't burn out and you really achieve what you want to achieve. And last week, we started with this module. You probably had your mentor call, or you should have had your mentor call. And there are 3 main pillars, let's say, for this module that we will discuss today. These are licenses, and as we are talking about open hardware projects, licenses that apply for hardware, for documentation, for software, for all the components of your project. Documentation standards, or how. Here we're going to give you some updates on how the community has been working to grow some organization around open hardware projects and documentation, and findability, because we are a lot of people, so it's becoming more and more difficult to find stuff. So do you want to give it a go from now on, Alex, or we can do it together? You are muted.
Thanks. Okay, yes, I can give it a go, and as usual, we do it together. You will just compliment what I'm saying, because I probably will forget something. Because today's session is all about licenses and standards, as Julieta already introduced, and both of us, we are no lawyers, and please, we are not liable for all the things we are now saying and telling you about the licenses and standards, but we are doing this and we are giving all the information we have to you because we want to, well, yeah, inform you about what's out there, what does it mean, and so on. But one of the reasons why these sessions, why these modules actually contain most of the resources we have in our curriculum, we will always reference these resources, and you are welcome to look at them and get more information from them, because, as I said, we will give you a rather broad overview over licenses and standards now. So again, please look at our module in the curriculum, take a look at the resources. As I said, there are quite a lot of them. The agenda for today is, as Julieta already introduced, to give you an overview over the licenses and talk a bit about standards for documentation and standards for findability. And we also want to know how you are planning to use or already using these in your project or projects. All right. licenses on your own terms. Please read this module. I think this is one of my favorite modules of our curriculum. In the very beginning, we introduce, well, the main difference between patents and why patents actually are limiting innovation in a way. And as a big example, we bring 3D printing, because I just want to give you a short wrap up. If you want to know more details about that, if you don't know them yet, please take a look at the module. But 3D printing, or the concept of a FDM 3D printer, was patented for a long time. And when the patent expired, it was taken up by, well, groups, open hardware groups. And one was the RepRap team, which was actually at the University of Bath. That's where Julieta is now located. Anyway, and they started with the RepRap project, which then led, among others, to the birth of the sister company now from Prusa. So the Prusa printers, which are well renowned, I think, but basically originate directly from the RepRap projects. And this was only possible because there was no patent there protecting the designs and so on. Why? Yeah, well, the question is always, where people are always coming up with, well, if I put something online and I don't patent it or put anything to it, then people will steal it. And so I need to patent it, but that's not really true. So what you can always do is also you can use licenses, and there are also open hardware licenses. And actually the best way to avoid from ideas to being stolen is to talk about them as early as possible, actually, in the open. And if you put something in, for example, in a website or in a repository, and, well, write a blog article about it, nobody can claim that you did not have this idea at a certain time point. Because, for example, if you want to file a patent, or if somebody else wants to patent then your idea, that's also something people fear sometimes. That's not possible anymore, because it has to be something original, like for a patent. So that's why we highly recommend to go open as soon as possible, but not just like that, but also add a license to your projects. And that's what we want to talk a bit more about. The license basically protects the design itself. A license does not tell you anything about how original a work is. It just protects, or, well, protects in a way. It describes or tells you more about, like, how to treat the design, like a certain variant of something. Yeah, we will get to this at a later stage in more detail. But what I want to introduce to you now are the different elements of a license.
Sorry, there, just a very quick comment, that it's really, really important to understand, even if we're talking about hardware, what is licensed, again, is the design. We're not talking about a physical object. Okay, so you license the design, and in fact, what other people, when other people manufacture from, in the case they manufacture from your design, it's not protected by that. Okay, so there are things like liability issues and things like that that do not apply, because, well, it was, you licensed the design, not the physical thing.
Exactly. Yeah, well, so the elements of a license is attribution, the use areas, and commercialization. I had problems pronouncing this.
The problem is the word of the week.
Yes, in the call yesterday, same problem. Anyway, and derivatives. These are all the elements of a license, and I want to give you an example. Well, a really well-renowned license are the CC licenses, the Creative Commons licenses, which are probably not a good choice for hardware pieces per se, but we will get to that as well, because you probably will need multiple licenses for a single project, which covers different areas of your project. Anyway, I want to use it as an example because you have the CC0 license. The CC0 license is like the license which does not require any attribution does not restrict any commercialization, and does not, well, basically does not restrict anything. It's really permissive. Everything is basically allowed. Then you have the CC BY licenses, which want some kind of attribution. And attribution means that, for example, our curriculum is licensed under CC BY, which means that if you are using parts of our curriculum, you are free to do that, but we want you, or the license requires you, to have a reference that you write somewhere that you took it from open hardware makers, and that's it. Right? So you can do and use it and do whatever you want, but you need to, well, reference the origin of it. And then you have also the commercialization part, and there are also Creative Commons licenses, the NC, the non-commercial licenses, which actually restrict commercial use. But, and that's a very important part, and that's nothing we just came up with, but if you publish something under a non-commercial license, it's just not open hardware. So that's something we want to be really clear about, and that's not coming just out of our heads, but that's also something we will talk about later. The certification by OSHWA, the Open Hardware Association, it also requires you not to restrict commercial use. So this is like a key element of open hardware. So it does not restrict that. And I'm repeating this quite often, but that's also important because many people, well, don't know that maybe.
Yeah, there is an association. You will probably find this when you're trying to explain others what you're doing with open hardware. You will very frequently find a misconception that open hardware is something that you cannot commercialize, but in fact, this is super wrong. And this is something we should try to enforce as we explain other people what we are doing. I mentioned this yesterday, but it's very annoying when you get when you find a super interesting project and you want to reuse what they have done and you don't look at the license and you do your work, and then you find out that this was a non-commercial license. And for example, if you wanted to do something commercial with it, then you wouldn't be allowed to. And that's really annoying. That's not open.
Yep. So yeah, we will talk a bit more about the standards and also about, like, well, if we are talking about commercialization, we might also have to talk about industry. And actually there is a open hardware standard for documentation for industry. We will talk about this later. So commercialization and open hardware goes very well together, in fact. Anyway, so something I did not talk about was the this word's really derivatives. Damn it. Anyway, so if you build upon another project, and that's also something Julieta was mentioning right now, you also have to check what's the license of this original project, because some licenses are copyleft licenses, which means that you need to use the same license, an open source license usually, for the part you basically reused, and maybe also for greater parts of your project then. So please take a really close look at that. I want to talk a bit, go ahead, Juli.
No, that if you're familiar with software licenses, this is kind of the difference between GPL and MIT or this kind of thing. That you should, well, Alex will talk about this now, but you should really think about what you want with your project. If you have the greatest impact in mind, if you want to really make sure that everyone shares openly downstream, these are questions you should start thinking about for choosing your license.
Yep. So you have to also decide about if you want to use a copyleft license, which, well, copyleft, the thinking behind it is that now then the license and the openness, let's say, or the open hardware-ness spreads like a virus, because it's like the open hardware pyramid scheme, because you have to use it in the other projects, and this way it propagates, but you don't have to
share alike. right? Like the Creative Commons shared alike is that scheme.
Exactly. Thanks. Exactly. That's the share alike. So, but let's now talk a bit more about how does licensing for open hardware projects work? Because, well, what do you see usually nowadays? And we were talking about this yesterday for a long time. You see many people with smaller open hardware projects using, for example, CC licenses, like Creative Commons licenses. But in fact, there are specific hardware licenses, open hardware licenses, and one which we want to put in the very front at the top because it's quite new, it has been reworked, is the CERN open hardware license. It's actually one could say these are actually 3 different licenses with different levels of permissive, being different in
permission. I don't know. No, but I don't know. I don't know what if the word exists. Yeah.
Permissive. So it's permissive. That's the adjective, and it gets more and more permissive. There are different levels of that. Right, but
that's the version 2. That just bear in mind that you will find the most recent version of the CERN Open Hardware license, which is number 2, is the one that includes these 3 options. Before, if you find 1.2. It has been there forever, like it was like the very original one. It was very copyleft, let's say.
Yes, and then other licenses are, for example, SolderPad and TARP license. So I think you have in the notes also like the small overview. Juli put it here for you, so you can see also the different licenses. And we know that you probably want to have a recommendation, and what we can recommend is, at least in my opinion, the new version of the CERN open hardware license, the version 2, and you can decide about how permissive you want to have it. That's what we recommend you if you don't have any clue and you don't know what to do. But now to the big but. Or do you want to?
No, I just want to say that in the notes, if you go, I added a comment saying some extra readings. After this call, besides reading the curriculum, if you want to choose a license, there is a text, there is like a publication for the European Commission that is really long, and it may not be interesting at all if you are not into this, but it has a very interesting table, I think by the middle of the document, that compares all the licenses and against like 18 criteria. And it also has a section on what to take into account when choosing a license. So I think that's really useful.
Yes, it is. But now the important point is that you probably need multiple licenses because part of your projects are usually quite different. So you usually need, let's say, 3 licenses. One for your documentation, and usually also the CC licenses go very well with that, so the Creative Commons licenses. Then you need one for your hardware, and that's what we were discussing right now. So for example, cut designs and so on. That's the CERN open hardware license, for example. And then you need another one for your software if your project requires some software, if you're programming a microcontroller or something like that. So these are the 3 different parts, and maybe there are actually more in other projects. Maybe they need even more licenses, but these are the usual parts a project has, an open hardware project has. So now the big questions or the big question I want to put. No, I don't want to answer it now. I actually want to ask you what you think, and if you have any questions. So what's the best license for your project? And which are your goals and how do they align with the available options in regards to attribution, copyleft, non-copyleft, etc. And which license for which components. You can take a look at choosealicense.com, and we will keep silent now for 5 minutes, but please go ahead, open your mic and give it a go, ask a question and respond to the discussion and so on. But you can leave us also comments in the document, and Juli, please read them if they are coming up.
if you go to choosealicense.com, that is mostly designed for software, but there is, I think there is a very interesting part that says, well, my project is not software, and then you can see all the Creative Commons for documentation. They mention the open hardware licenses. So I think, I don't know, I think it would be nice to hear from you if you have given any thought to at least copyleft or not copyleft. I think it's a very interesting discussion, and it's a forever discussion in the software world, right? Have you given any thoughts maybe about thinking of attribution? Have you ever thought about choosing a license for your project or not? Feel free to just unmute yourselves.
All right.
Yeah, I can share some. I mean, I've definitely thought about it. I've written software in the past, and I've actually never bothered to put any attribution or anything that I wrote, because I never felt it was, it had enough IP in it to actually justify having a license, right? I always just felt, oh, this is super lightweight. Anybody could have done this, so there's no point in putting a license on it. And that's still a little bit for how I feel for current projects that I'm working on. However, I do understand that for certain projects, it's super important. And reading through all the documentation and the reasons why you want to have copyleft, for instance, or maybe why not, that did open my eyes. So what stood out for me was the fact that you might have, I think Rails, the programming language was mentioned. Rails being open source, but you might not necessarily want all your software to be all the derivatives being open source, because you want it to be picked up by the community, and you want companies to start using it, and those companies might want to close it down. And that's not necessarily a bad thing for your software, because the adoption grows. Whatever is built with that software is not necessarily has to be open sourced as well. So that really opened my eyes to the difference in whether you want copyleft or not, and whether that's a good thing or not.
Thank you. I mean, well, I think putting licenses in your code is maybe a bit different, but with the hardware projects, it might be also a good idea. I don't want to scare you, but also for liability, right? So this is also something you might want to consider.
Yeah, it's just something on the backlog, right? It's just priorities right now, but yeah, it's definitely going to be on there.
No, but yeah, I think it's also great because I think with software, it's more the discussion is more mature. There's so much that has happened in the last, I don't know, 20 years about this, and the free software and the GPL and the open source community and differences. But for hardware, it's also good to start. I think when there is a difference in when you go to a repo and you find the license, and to try to understand that, okay, the person has thought about the terms of use of the design, and if it's copyleft or not. Well, it will, as you said, Lawrence, I think it will absolutely depend on the context in which you're working. Also, if you want to encourage a lot of company uptake, at least that's what happens in the software world, right? They prefer like a more non-copyleft version.
Yeah, maybe one more thing to add. What I just realized as well is that if I don't mention anything, basically nobody can use it, right? Because then they might be liable. So I think that alone already is a really good reason to actually put something in there. Because as you mentioned, Julia, that at least then I show that I thought about it, and that should make other people more comfortable in copying and reusing it.
Yeah, and I think it's also like an education tool. There is I don't think anyone reads a license, but oh look, it's CERN involved in this? You know, that's the first question usually. Oh, CERN open hardware license, is CERN involved in this? And then, oh no, CERN wrote a license for this. Wow, okay, what is open hardware? You know, this kind of change starts happening, which I think is good.
Andreas, you unmuted yourself.
Yes, I did. So, yeah, we thought about licensing a bit as well. So as you suggested, we also will like divide it up in 3 different licenses probably. So yeah, documentation would be some Creative Commons license. For software, we actually have some software which we made a derivative ourselves. So we are choosing the license from that. And we'll probably have some original software as well. Maybe we're going for the GPL with that. For the hardware, we definitely want to use one of the CERN V2 licenses. We're currently discussing which one. I had a similar discussion in another project, and one of the things which came up there was that so we actually wanted to have kind of this viral effect like the GPL in the hardware part as well. But to our understanding, it is, well, the licenses in hardware work in a different way than the software licenses do, because the software licenses rely on copyright. And whenever you write software, it's automatically copyrighted. And that's different with hardware. So, for example, if you're designing an electronics circuit, you are doing a layout for that and doing a PCB, it's not clear or immediately clear that everything is copyrighted, and it's pretty easy to get around the license by just re-implementing the same circuit, just laying the same thing out again and producing PCBs for that. So
can you explain a little more on that, Andreas? Because I think this is something we didn't explain a lot about.
Yeah, well, I don't know if I can explain it completely.
But it's okay, it's in your words. And
so the understanding I have is that in hardware design, you have different mechanisms to ensure that your ideas are not copied. And in hardware, the main thing is patents, and that's different from software. So with software, you always have copyright, and you cannot really do anything about it. As soon as you write software, you have the copyright on that. And the GPL license, for example, just uses that right you have on your code, so you can enforce some license on it, and meaning that others have to do certain things if you want to use your code. But if you do not have, if you're just implementing some electronics circuit, you really have to prove that that's something new about it, and not just like a clone of something else. And if you really want to enforce that, you have to have a patent on that. And if you don't do that, you do not really have any legal mechanism to protect your license. And so
yeah, yes and no, like it depends, right? So if that's true for the object, but for the design, if you apply the open hardware license, what happens is that there is no yes or no answer to can you protect the design, right? Because as you were saying, most of the time, if your design is very similar to available functional stuff, then you won't be able to protect it. But if you have, there is a really nice tool in the open source hardware certification website that I will link afterwards. If you have more like artistic, for example, things around your design, or you have very specific things that are not available out there in your design, your hardware design, then the open hardware license can be more, you move towards the more protectable side of the spectrum, let's say. So yes. I think that is important to think, because some of your designs, I think, in fact, Andreas, yours has a lot of protectable stuff. I don't know, maybe it's wrong what I'm saying.
Yeah, but I don't know. Maybe you're totally right. Like you can have like trademark rights on the
brand,
on your design and everything. And but well, in our case, for example, I don't think we have that much like originality in our electronics circuit. That's kind of standard things. So, and well, our conclusion in the other project was that we are using the permissive license from the CERN open hardware license, because we were not sure if we could protect it anyway. So if some big company comes along and wants to copy it, they will find a way anyway to do that. And we cannot protect, we can't do anything against it, basically. So we are not like moving blocks in the way of like the standard open hardware enthusiast and just make a permissive license of the whole thing. And yeah, I don't know.
That's really good discussion. Yeah. Yeah, that's super interesting. I put there the link because it's really case by case. And they have, if you go to licensing there, you can see different examples of the spectrum of less protectable and more protectable that we were talking about.
Maybe. But I like, for example, the idea what Arduino does, that they basically open the design completely, but what they do is they make strict protection about their trademark. Yeah, and I think that's a fair.
That's a really that works quite well for them, right? And their hardware has been cloned everywhere in China and everywhere, I would say. But anyway, it works. So for those of you who are not familiar, what Arduino does is just has a trademark. So that's why you have the Arduino compatibles or things like that, no? Alex, I think you unmuted yourself.
I think I'm unmuted. Can you hear me?
Yeah.
Okay. One thing I want to mention in this, maybe the same thought, is that there's basically no way that you protect your schematic. You can protect your physical form of your schematic, like your PDF, but the idea inside of it, there's basically no way to protect this. Anyone could recreate your schematic without breaking any license.
Can you repeat that? Can you rephrase that? I didn't. Sorry. Maybe Alex, you understood better. I didn't.
Well, if you want to give it a go again, but it's just more about that he wants to like emphasize that it does not mean that anybody can just do whatever they want to do with the build, then with the design itself, like the schematics, like the cut design. That's what I got from that a license does not really help with that. Is that?
Yeah, only the cut design is protected. The idea behind it, there's no. If you just throw enough money or time at an idea, you can replicate the same thing.
I see. So all the thinking process and so on, that's something which is also not like manifested anywhere. That's something which has to be basically then followed and recreated, right? That's what I got.
And that's what's interesting about openness, right? If you just release the CAD and expect someone to recreate it, it will be much harder for someone to try to replicate it. That's why we put so much effort in all that know-how and the documentation part.
And that's also part of the discussion about like how to commercialize something, and how can you commercialize something if you put it as open hardware somewhere, because you have the knowledge, you have the experience, because you build it, and that makes the big difference in our understanding. Anyway, is there?
And you need the knowledge also from the industry, right, to commercialize it. Yeah.
Is there another question to this part? Because otherwise I would go to the next one, to the standards. Is there something in the doc? All right. Then let's talk standards.
Sorry, I was muted. Sorry. There is. We are a charity that produces hardware and software for people with disabilities. What type of licenses would you recommend for us to use? for our projects, is it possible for us to apply the same licenses to all our projects, or we recommend to evaluate on a case-to-case basis?
So we don't, I think, but I tried to speak for the two of us, but please correct me, Juli. So I just don't want to recommend one thing, but I can tell you what I do. I usually do, I have a standard license I'm using, and that's CC BY for documentation and code usually, or GPL for code, and the CERN Open Hardware License version 2, the permissive one. That's just my standard, and that's what I'm using. But then if I have the time, because it's always a time issue, and I'm really thinking about like, okay, what's the goal of this project, I also think about the license a bit more, right? So because you usually have like also a lot of smaller projects, right? And to be honest, I just dump like the 2 licenses in there, and that's it. And if there's something like I want to consider, for example, that I want to have one project less permissive, then I change that.
Yeah, I would totally go on a case-to-case basis, but also consider, I'm not sure about the whole process you have. So you produce software and hardware for people with disabilities. Do you have, I would think about, do you have partnerships with companies who then massive produce this, or are you going with small manufacturing and people who won't have any trouble with with more permissive, less permissive? So I would start thinking of who your partners are, and if it's, I would always incline for the permissive one, but maybe this may bring trouble with some business partner in the future. So I would totally consider on a case-to-case basis. For documentation, I would go with CC BY, as Alex said. For software, I think it's really tied to the hardware license, the copyleft or not that you choose. If you want also, we can, after the call, we can contact you with someone who knows more about licenses. That's also an option.
But also take a look at our resources, because we put a lot of effort in collecting them, and there are quite a few which actually help you to decide which is the best license for yourself, for you.
Yes, last resource, we can contact someone. First, let's try to read everything before.
Exactly. Okay, now about standards. Standards are good if you want to, well, have something in a way that everybody understands it. For example, documentation. There should be, like, let's say, a guideline, a structure, and so on, which is like the standard documentation. That's good because it helps you, because you know where to start and what's your goal, right? So that's why standards are important. And another really important part is, it's, for example, about certification and so on. If you want to have a certificate for something, like the Open Hardware Association certification, you need to follow also certain standards, documentation standards. And then I quickly introduce it, and then we'll talk about that in more detail. Also the DIN spec 3105, which might be a bit a German thing, but anyway, it's a, well, let's say an industrial mechanical open hardware standard for documentation, which contains a lot of details about which files should be shared, which schematics should be shared, and so on and so on. And well, you can officially get this DIN spec certification by applying. You can have a quick look at it at the webpage, the link. I think it should be also linked in the document, so you can directly access it. It has a lot of details, and it's, let's say, more targeted at projects which have a lot of mechanical components. The OSHWA certificate is a bit different. It's also a documentation standard, but it's a bit more, let's say, soft. It's it has certain things which are important. So you have to have a license, which allows, for example, commercialization and so on. And it has a lot of boxes to check, but it does not name, as far as I recall, certain file formats and so on. So it's a bit...
They suggested editable formats as we do, but
exactly,
they do not enforce it. Yeah.
And they also don't say, well, you need to have it as PNG or PDF or whatever. They just say it has to be editable, not edible, editable, and sorry, and
edible would be nice.
and so on, right? So that's something we highly recommend you to take a look at the OSHWA certification. That's actually something what allows you to put, like officially allows you to put the open hardware logo on your designs if you want to do that. It also gives you a registration number, which might be also useful for you if you, for example, if you're doing this and want to get funding, want to get money from people, and you want to show them, well, this is officially certified open hardware and fulfills certain standards. Juli.
It's a way also of recognizing your work, right? Because as you may have guessed from all this program, Going Open demands some work. And the good news is if you fulfill like the assignments that are there inside the curriculum, you will be really close to the certification. So there's not a lot of work you will have to do to certify. And in fact, we would love to help you getting certified after the program. If that's what you want to do, let us know. But it's a way of showing I care and my project is truly open. Like the source is there, anyone can go and replicate it, and I've done a lot of effort for that to be possible. I think that the inspec is a bit more advanced and for projects that have a more industrial profile, but it's always interesting to, I know it's a German thing, but it's quite, it's something other people in other countries also look at. So if you're in industry, that's interesting.
I don't know anymore if Mo joined, so Martin Heuer joined in this cohort, but he gave a call also for open hardware makers, and he is one of the people who was involved in the creation of the DIN-spec. This is a community of people, parts of the open hardware ecology, Germany, open source ecology, sorry, Germany, and there has so many overlapping people in the different organizations, because another one we want to introduce you now, and this is now the link to the next standard, is the open know-how and the Open Next project. He also talked a bit about Open Next and what it does and what they plan to do with their library of open source hardware.
And this is in YouTube, right? Even if Martin didn't join this call, I think it's in YouTube available.
Yes, it's on YouTube, but you can also take a look at the websites and read about what's there. Findability standards. Findability is also very important. We will talk a bit about the community aspect of findability and platforms and where to put it and how to talk about your project and so on and so on. But now more about the technical side. So there is this open know-how community. I think it's actually no, I'm not sure. Open Hardware Observatory is a non-profit. Anyway, technical detail is not important, but it's a community, it's a group of people who thought about how can we make open hardware projects more findable, cross-platform. And they came up with a standard. Actually, it's a manifest, a file, a YAML file. It's just a type of file, which you have to add to your project repository or whatever, wherever you host it, which contains the most important information. And it has to be also in a certain format, like internally. So please take a look at the open know-how. And what it then does, it lists it in the open know-how, what's it called, collection or repository? Well, anyways, the library of open source hardware works similar. I think from what I understood, what Mo or Martin Heuer introduced to us is that they developed a web crawler which crawls the web looking for open hardware projects, and it then adds it to the library of open source hardware. So they are, for example, also looking at just like Thingiverse, 3D designs and so on, but also Wiki Factory, GitHub, and YouTube, which, as I got to know, is actually also a really important source for many people for open hardware projects, because for people who have no clue about open hardware and are not in the community, sometimes first look at YouTube if they find, for example, how can I build XYZ? Well, you probably ask yourself, how does it identify open hardware projects on GitHub? For now, as far as I can remember, as I recall, Mo said you need also a short manifest file, just something which contains the most important info and which is then detected by the crawler and then listed. So it should be also your goal to be listed in either of one resources. So please take a look at it. Please take a look at the standards. And usually it's just super simple. Just generate a template. They have on their website also a template generator, and then just fill in like the specific info and you're set.
Yeah, it's really easy, and we really recommend it, because as you may probably know, finding stuff is really complicated. And projects are very different. So the standard, the template asks you for some key information that was, those criteria were discussed in the community. So it's something that people think is useful. I just pasted a link to the search engine of the Open Know-how standard, and you can get a clue, get a feeling of how it looks if your project is listed there. All right, should we move towards a very quick discussion on standards?
We unfortunately don't have a lot of time left, but yeah, please, that's the time to open your mic or type some questions, whatever, into our document and see, well, which are the standards you find more useful, and
have you ever worked with standards?
Yeah, exactly. And how can standards probably or might help your project? So do you want to use it, or is it just something you put just at the very left, very bottom of your to-do list?
Hey, Andrew, I see you yourself, but I only hear your background noise, unfortunately.
Yeah.
We cannot hear you at all. Would you mind writing in the chat?
We cannot hear you.
I'm sorry for that. The connection, the audio doesn't work. Sorry, I'm gonna mute it now. So, but hey, Andrew, I'm really sorry for muting you. But can you please add anything you want to say in the chat if you want to? We will be looking at that. Have anyone heard about Open Know-how or the library of open source hardware, or, for example, the Open Hardware Repository, which is something that has been around forever by CERN? Have you had any experience with that?
So no experience with any of those. But like using STL files for 3D printing or using fritzing files for PCB design, would you consider those standards? Because to me they are, but that's just put in my circle, right? So because I'm used to using fritzing, so that's what I look for, and I find a lot of things in fritzing, and I use STLs, and so I find a lot of things in STLs. But when do you consider something a standard? Yeah.
Well, that's a really hard question, right? I mean, there's a big discussion about how suitable are STL files actually for 3D printing. Anyway, I don't want to dive into that, but the standards we were talking about are a bit more a level above that, right? So it's more about how do you structure a open hardware project, a documentation of an open hardware project, not like this tiny details of the not true. The DIN spec does do that. Yeah, and it does it in a way. It actually, sorry, I have to. Sorry, I actually don't know more about how they actually let it be a standard or how they decided that it is a standard. But I think actually they had a huge group of people sitting together and discuss it.
Yeah, I can tell you more about that. So I think the difference, what you're mentioning, Lawrence, is that when a file format becomes a de facto standard because people start using it and sharing it, and that's okay. There's a whole other discussion, as Alex was mentioning, on STLs and 3D printing, and we can talk about that another day. But for example, I don't know, Android becomes a de facto platform or de facto standard because everyone is using it, let's say. But this is a more meta definition of standard, and these two, in fact, the library of open source hardware, I think, is a derivative of open know-how. Open know-how was a group, was a process led by the Internet of Production Alliance, which is a non-profit working in this space, trying to lay down like the infrastructure for an Internet of Production. And what they did was get together a lot of people. And after many discussions, they decided which is the information we need, the minimum necessary information we need from an open hardware project to understand what it is about, what it can be used for, and other things. For example, is it contributing to a sustainable development goal, for example, right? Because that's something interesting for some audiences. Or which are the minimum technical requirements for implementing this project. So they agreed. It was a very complicated process of agreeing on a lot of criteria. And that is the information that goes into the manifest. So when you download the template, that is what you complete. And that is what the crawler afterwards looks for and puts in the search engine. So it's like a meta standard. And what I understand from my experience with Martin Hoyer's work is that they took that and forked it and changed some things to kind of making it more easy to implement. That was my experience with that. Okay. The DIN is different because it's more industrial oriented. So it has more industry minded people and typical standards like the ISO mindset on that. And I see, Andrew, you work with open know-how. That is great. And if you want to share with us your repository with the manifest, that's also a great example to show. And feel free to paste that in the chat.
Yes. But if there's no urgent question right now, I would actually go to the next slide. So we are in time.
Yes.
Because we want to remind you about the next steps. Please make sure, as always, that you have scheduled a meeting with your mentor next week. There's no cohort call next week. We see each other back on June 15th. And, well, you will receive an email. Next week, it's all about community and communications. And if there's something coming up, if there's a problem, if anything, just contact us. You know how. And now,
just FYI, it's June 16th. I forgot to update that. But yeah, we see each other in 2 weeks, right?
Yes.
Something important is that, as I mentioned in the very beginning, we are on week 11, and week 16 is the final week of this program. So we are like a month away from the final public call. And this is the best moment for you to start thinking about your demo if you haven't done it yet. We suggest you start outlining how you will present your progress through the program in up to 3 minutes, 3-4 minutes max. You can use whatever format you want, but there will be some specific guidelines that we will send you on what you need to present the day. Seize the chance to discuss it with your mentor. Bring your questions to the next community call, and because we have the next cohort call, we have the topic of community and communications, so it will probably help you thinking of that. And we always try to make sure that you understand that the public call at the very end of the program is a chance to showcase your work and connect with people you want to connect. So if you know of people you would like to be aware of your project, this is a good chance we can contact them, we can invite them to the call. We will live stream it anyway, but if you already say, oh, you know what, I'm working on this kind of space and I know this person who would be great to contact, well, we can reach out and try to get this person into the call. So let us know, start thinking about your demo project. If you have any doubt, of course, you can email us and we'll help you.
With this, we want to end for today. Thank you very much for joining us. If you want, you can leave us some comments. Juli, unfortunately, I have to leave right away. I don't know if you have 5 minutes to stay in the call.
I can stay for 10 minutes. Thanks, Lauren. See you next time. I can stay for 10 minutes if anyone wants to has any burning question. I will stop the recording now.